Hi, I'm Guang 15 years old. In this lesson on the techniques and applications of definite integration, we'll take a look at these two questions on double integration. Right, so we'll take a look at the first example, where you have double integration over the boundary of d, e to the power of y to the power of 4 dx dy, where d is bounded by x is equal to y cubed, y is equal to 1, y is equal to -1, and the y-axis. So, when we first look at this question, we need to know what this boundary looks like. So, starting off with the boundaries. We have an x-axis, a y-axis. Now, the x is equal to y cubed graph. You might already know what y is equal to x cubed looks like. So, x is equal to y cubed will just be that, but reflected about x equals y. So what you originally have as this, you now have this part over here. Right, so this is our x is equal to y cubed graph. Now we need the lines y is equal to 1 and y is equal to -1. So we have y is equal to 1 and y is equal to -1. Right, so the area we are integrating over would be separated into two different parts, which is these two, alright? So one above the x-axis, the other below the x-axis, which in this case, you have to be aware where you integrate to, where you integrate from. So this you can write it as y is equal to cubic root x, or just x is equal to y cubed. It depends on how are you going to integrate them. So let's take a look at how I'm going to integrate these two parts separately. But of course, we might want to find out what these 2 points are. So since you know the function of this graph, you just have to sub in y is equal to -1 and y is equal to 1. Well, you will realize this is -1, -1, well this is 1, 1. Right. So this is what we will have. Right. Now there are one way of solving this. Well, if you're wondering what if we integrate, whether depending on you want to start from x first or y first, you have to look at the integrand. So the integrand is e to the power of y to the power of 4. But e to the power of y to the power of 4, if you integrate with respect to y first, that is not solvable. So you have to integrate with respect to x first. So you have dx dy. Right, so dx dy, that means you're integrating with respect to x first, and it's going in this direction. Right. Now, we can take a look at the part that is below first, where you have x is equal to y cubed to x is equal to 0, since the y-axis is basically x is equal to 0. So from y cubed to 0, and here you have the y range of -1 to 0, while the other part, when you integrate with respect to x first, will be, so now it is from 0 to y cubed, well here you have from 0 to 1. Alright, so this is what you will have. Now we can integrate for both parts already. Since when you're integrating for x, those terms with y, as long as you multiply onto the other terms of x, you'll take those other terms as constants. So that means e to the power of y to the power of 4, when you integrate with respect to x, you'll take that as a constant. So you are just going to have e to the power of y to the power of 4 x. So you will repeat the same process for the term behind. And of course, then you have to substitute your value, where you will see -e to the power of y to the power of 4 y cubed dy, and then add on, integrate from 0 to 1, e to the power of y to the power of 4 y cubed dy. So for both of these terms, you can choose to individually put y cubed inside the dy, or if you can realize it, this graph is more or less symmetrical, and well, you can think about how you can overlap these or make these two the same. Alright, so the first one, we're going to have negative 1 over 4 integrate from negative 1 to 0 e to the power of y to the power of 4 dy to the power of 4, and then add 1 over 4 integrate from 0 to 1 e to the power of y over 4 dy to the power of 4. Alright, so next we can just integrate whatever you have here already. Well, you're going to have negative 1 over 4 e to the power of y to the power of 4. Then substitute in negative 1 and 0. Well, for the positive part, you just substitute in 0 and 1. So from your first term, when you substitute in 0, you're going to have negative 1 over 4, since e to the power of 0 is just 1. And then when you substitute in negative 1, you're just going to have e to the power of 1. But this time you have add on 1 over 4 e. So now you do pretty much the same for the second term, where you substitute in 1, you're just going to have plus 1 over 4 e. But when substituting in 0, you're going to have negative 1 over 4. Right, so you can just combine these two parts and you get half e minus 1. And this will be your answer for the first example. Right, so the process should be rather simple, since what you did was just to determine what the graph looked like and separate it into two different parts to integrate them separately. And afterwards, it will just be some calculation and to get the final answer half e minus 1. Right, so that's the first example. Next, we'll be moving on to the second example. Right, so for our second example, we'll see double integration over the boundary of d, 7x squared plus 14y dx dy, where d is bounded by x is equal to 2y squared and x is equal to 8. Right, now for this part, of course, firstly, we will still have to look at what the boundary looks like. So x is equal to 2y squared, which means there will be no negative values for x, since we are just looking at real numbers here. So x is equal to 2y squared. And x is equal to 8. Or I'm just going to put this 8 on the other side, since if you realize the area bounded would be within this portion. And next will be to determine the two intersection points. Since you're going to have 2y squared is equal to 8, while y squared is equal to 4, you're going to have y is equal to 2 and negative 2. So you're going to have 8 negative 2 and 8 2. Right, so that means for this part we can start integrating. Well, of course, you can choose to start integrating with respect to x and choose to integrate with respect to y. Just you have to be aware for the different boundaries. Alright, so with this we're going to have integrate from, so since it is in the x direction, that means you're going to have from 2y squared to x is equal to 8. While for the values of y, you're going to have negative 2 to 2. Alright, so this is pretty much what we're going to integrate. Now just integrating with respect to x, we're going to see 7 over 3x cubed plus 14xy. Then substitute in 2y squared and 8. Next, we're just going to substitute in the different values you will see. So integrate from negative 2 to 2. You're going to have 7 multiplied by 8 cubed over 3 minus 7 multiplied by 8y to the power of 6 over 3 plus 14 multiplied by 8 then multiplied by y, which is 112y, and then you have to subtract 28y cubed, which is you have to solve this part over here. Now, since this is just a simple algebraic integration, you can rather easily solve it. So we're going to have x and then negative, so y to the power of 6 becomes y to the power of 7, removing the 7 from the front. I mean, this is y not x. And then add on 56y squared minus 7y to the power of 4. And next you just have to sub in the values of negative 2 and 2. So for this part, you can choose to use the calculator to solve it, since there will be quite a bit of process trying to solve it. Alright, so if you got this right, you have the answer of 4096. Alright, so that should be your answer for this question. Right, so this question, well, it is pretty similar to the first question in terms of how you solve it, since all you do is take a look at what the boundary looks like, determine how are you going to integrate, whether with respect to x first or with respect to y first. Well, in the first question, you have to integrate with respect to x first. But in the second question, you can choose either one to start with. So that is pretty much all for these two examples over here. So I hope that you understand both of these, and I'll be ending this here, and thank you for your watching.